In this video, we'll learn how to use printf in C to display text and values on the screen, starting from simple messages and moving toward formatting numbers neatly in columns. Printf is a function from the standard I/O library, stdio.h. It prints output to something called standard output, which usually means the terminal. Let's see the proverbial Hello World program in C using printf. We've included stdio.h file. Inside main, I'll insert a call to printf with the text, Hello World. Since Hello World is a string that we want to display, it is inside double quotes. This is an argument to printf. It is called a format string. We'll see why later. Let's compile the program and see what we get. I compile the program. Then I run the program. We see the text Hello World on the screen, but it is immediately followed by the terminal prompt, so it is hard to see. Unlike the output functions in some other programming languages, printf does not automatically insert a new line on the output. That is easily fixable, though. We can insert a new line at the end of the text, Hello World, by including the character sequence \n. Let's recompile the program and run it. Sure enough, now there is a new line after the text, Hello World. \n represents the new line character. In C, you can place it anywhere in the format string to cause the output of a printf statement to be split over multiple lines. Let's see an example. We can add some text after Hello World in our program, followed by another \n. Let's recompile and run this program. Now we see Hello World, followed by a new line, and this is C, followed by another new line on the screen. \n is an example of an escape sequence. There are several other escape sequences in C for different purposes. All escape sequences start with the \ character. \ is called an escape character in C because it escapes the usual meaning of the character that follows it. In our example program, without the \, an n would be displayed on the screen. But the \ changes how printf interprets the n and changes its meaning to displaying a new line. Another escape sequence is \t. It represents a tab character, which causes the output to be indented. Let's replace the \n in our current program with a \t to see what this looks like. Now the two sentences are separated by a few spaces, a tab character. What happens if you want to display a \ character on the screen? Let's try typing the \, as is in the argument to printf, and see what happens. When we compile this program, we get a warning. The compiler tries to interpret the \ along with the next character as an escape sequence, but it complains that \t is an unknown escape sequence. To display a \ to standard output, we must type two \ characters back to back. The first \ character escapes the meaning of the second \ character. Instead of interpreting it as the start of an escape sequence, the compiler now interprets it as the \ character itself and displays it literally on the screen. Suppose we want to display the quotation marks on the screen. Let's try adding those to our program around the word world and see what happens. The compiler shows an error on line 4. What happens is that the string that seems to start at the first quotation marks ends at the second quotation mark before the word world. As this marks the end of the format string, the compiler was expecting the printf parentheses to close, or a comma followed by more arguments, not the word world. To fix this, add a / character before the quotation marks. Now, the program runs fine and shows quotation marks around the word world on the terminal. So far, we've displayed fixed text on the screen, but programs are meant to work with variable data. Let's see how we may display variable values using printf. Let's replace the format string with something that displays the year. To do this, we need to insert a format specifier, in this case, %d. This is done within the format string. After the format string, we pass another argument to printf. Let's use a literal integer value here for the time being. Let's compile and run the program. Now you see this is year 2026 on the screen. The %d format specifier is a placeholder. Printf replaces this placeholder by its second argument, the value 2026. %d is the format specifier for integer values. There are other format specifiers too. The second argument to printf, in this case, has to be an integer to match the %d format specifier. Of course, this second argument doesn't have to be a literal value. It can be an expression, as shown here. The compiler evaluates this expression and replaces the result in place of the format specifier. In this example, we could also use a variable to replace the format specifier, as long as it is also an integer. Let's replace the expression with a variable named x, initialized to the value 2026. If we compile and run this program, we still get the same output. There are other format specifiers for other data types. For example, for the character data type, there is format specifier %c. Let's use that in our example. We initialize a character variable to the value a and display its value using printf. When we compile and run our program, it displays, this is the letter A. Another format specifier is %f for floating point values. Let's use that in our program. Let's initialize a float variable and use it in the printf statement. When we compile and run the program, it displays, this is the value followed by 4.56 and some trailing zeros. That's the default precision that printf follows for floating point values. We'll see shortly how we can change that. To display strings, the format specifier is %s. Let's define a string and display it using printf. We compile and run the program, and we see, my name is John on the screen. Printf isn't limited to displaying one variable value. It can work with multiple placeholders, each replaced by successive arguments. Each placeholder can be any format specifier. For example, let's display a string as well as an integer in a single printf statement like so. Now the first format specifier %s is replaced by the second argument to printf, that is, the value of the variable named word. The second format specifier %d is replaced by the third argument to printf, that is, the value of the variable x. So the replacement of format specifiers is done sequentially with the arguments to printf. Each format specifier and the corresponding argument data type must match, otherwise you'll get a warning and unpredictable results. Another feature of printf is output formatting. There are three parts to that: the flag, the field width, and the precision. Let's start with the field width. The field width is specified as an integer after the %sign and before the data type specifier. Let's change the %d in our code to %6d. Now when we recompile and run the program, you'll see that the corresponding output occupies 6 columns, and the value is right aligned in a field of width 6. 4 places are used by the digits in 2026, and 2 leading spaces are displayed. If we use a field width value that is smaller than the number itself, then the compiler just ignores it. As we can see, if use %3d, the compiler still displays the full number 2026 itself. As for the flag, if we place a minus sign before the field width, the output will still occupy 6 columns, but the value will be left aligned. We can't see that because there's nothing but a new line to the right of 2026. Let's insert a period after %d to see the effect of the minus flag. The field width specifier and the flag can also be applied to other data types, even strings. Let's apply a field width to the %s format specifier. You'll see that the name is now right aligned in a field that is 10 columns wide. You can also use the minus flag to left align the string in this field. Floating point values also have the concept of precision. So we can start by displaying a floating point value at its default using %f. We can change the field width to 6, which has no effect because the number itself needs more digits than that. So printf ignore this field width. Let's increase the field width to 8. In addition, let's specify the precision as a number after the field width, separated by a dot. 8.2f means that the number will be displayed with 2 places after decimal and a total field width, including the point and the places after decimal, of 8 columns. You can change the precision to 3, and then you get 3 places after decimal. Apply the minus flag to left align the number in the field. Note that this isn't changing a variable's value. It just changes how it is displayed on the screen. In summary, printf can be used for formatted output in C. It uses a format string and format specifiers to display variable values. The field width, precision, and flags are very useful if you want to display data neatly, aligned in tabular form.